Okay, so we have a question about the average rate of change of this function on an interval. Okay, or function much like this on an interval. Given. So we can immediately go to the numbers, but we also have an interpretation. Okay? Now I'm just going to go ahead and do it with the numbers, but then we'll put the interpretation on it. So this means, always go back to the graph when you can. You got 50, you got 70, and you've got, scale isn't really good, negative 475. Negative 929, so you've got 2 points there. The graph doesn't have to be overly accurate. So we can do the fundamental triangle. The rise is the change in y. The run is the change in t. The average rate of change is change in y divided by change in t. So now we can always say all this, if it's a y versus t, rise is delta y, the run's delta x, the slope is rise over run, which is delta y over x, which is and it's not delta x, it's delta t. That is the average rate of change of y with respect to t on the interval 50 to 70, right? That's the definition. That's what it is. So now all we've got to do is find the rise. Well, that's going to be what? Negative 429 and 25 is negative 454. In the run, delta t equals 20. Y'all are getting pretty good about putting your arrows in things. We've got to have the arrows there to make sure we've got the signs correct. Otherwise, you might subtract this from this, or subtract this from this. And think the rise is positive or something, okay? Could be, if you want the arrows to go that way, your rise would be positive, but your run would be negative. Either way, you're going to have a negative slope, and you know that's a negative slope. So again, you want to look for consistency. Okay, you want to make sure everything makes sense as best you can. Okay, so that's well, I can even tell you what that equals. That's negative 46.45. Now, for the interpretation of this situation, that 145 isn't very important, okay? But if you have really precise data, you might need that much precision, okay? Okay, well, so there's the slope, and that's always, if I'd give you a function and ask you to find the slope on an interval, it's always the same. You find the two points in your graph, and you find the rise and the run of your fundamental triangle and find its slope. And you also need to understand why that is the average rate of change of y with respect to t. Because that's a definition, change in y divided by change in t. And the rise is your change in y, and the run is your change in t. So you want see everything there is to see in that picture. Okay, well, there you've got it. Now there are other questions. If you get that much, you've got a pretty good start on the problem. Okay? Then give real-world interpretation according to 3 different situations. Okay? Well, this is the easy part. I think everybody's in pretty good shape because everybody does pretty well fundamental triangles. Just got to know that average rate of change is associated with the fundamental triangle for the reasons I've given. Okay, so if y is water depth, in feet, the water depth can be measured with respect to any point. If you're in a deep body of water, you just figure out where you measure the water depth with respect to, okay? Maybe that big shark that's been staring you in the eye for the last 3 days, salivating, but you can't tell because, well, the shark's not salivating. Okay, but in the water, how would you know? Okay, so if y is water depth in feet, measured with respect to some point. Okay, so you're 475 feet below your reference point, then you're 929 feet below. Okay. So maybe you're draining the ocean or something, I don't know. So it's not a very realistic model, but we're still going to interpret it. Okay? And T is time in months. And what specifically is delta y? How did I get delta y?
By subtracting what it ended at versus where you started.
So I subtracted this depth from this one, right? That's what you said. Okay? There's my delta y. What would you call that?
The change.
Change in?
Yeah, water depth.
Yeah. It's a change in water depth. I'm nagging y'all all semester to write down the words, right? So you understand interpretations. It's somewhat challenging, okay? Y'all aren't doing great with it, but you're not doing terrible. So see if you can get great on it, okay? You know, every time I've done this, I've analyzed it in the same way. Okay? If you haven't picked it up, it's getting late, but you can still do it. Okay? Y is the change in depth. Delta y. And I keep telling you, delta y is not the depth. Okay? Delta y is the change in depth. Delta t is what?
Change in time.
Change in time. A change in depth in feet. That's a change in time in months. Okay? Average rate of change. I guess I'm going to write out all the words. I'm wanting to abbreviate because I've been using all the words all along, but since you all aren't using all the words consistently, I better write all the words. Average rate of change. So that's negative 454 feet divided by 20 months. And you can divide that out, you get negative 22.7 feet per month, a little less than a foot per day. And you want to try to make those associations. So you could say water's dropping. Why am I writing 10? Try to write it down. Less. Okay. The analysis, the meaning of a rate of change is always the same. You figure out the change in this quantity, you figure out the change in that quantity, you divide them, and you write down the two changes with units, and then speculate on what they mean. Okay? That's, again, this is kind of your last shot at getting this, and you can almost be guaranteed that it's going to appear in the test. Okay? Now I'm going to leave the other two alone because there's the procedure. You just fill in the words for the other two situations. And I'd recommend that you do that, hand them in next time, and draw my attention to the fact that you handed them in so I can look at them and see how you're doing with it and say a little more if necessary. Okay? So one of the most important things we do in this course is understanding rates of change. I mean, everything around us, you've got rates of change. A lot of you are moving on to a calculus course, okay, an applied calculus course. As I've advised you, if your curriculum permits it, and it almost always does, you really don't need pre-calculus 2. Great course, everybody should know it, but applied calculus is more important for most of your careers and your education, okay? And it's easier. I know, you didn't hear anything I said except the part about easier, right? Okay? That's okay. It's what you need. It's easier. Win-win.